8.1 is on Pythagorean Theorem. Our objectives for this section is to simplify radicals to exact answers, and we're going to use Pythagorean Theorem to solve for missing sides of a triangle. We'll also review how to find area of a triangle. Simplifying radicals means we're removing all of the perfect squares that are underneath the radical sign. So we're going to go over a few examples. We are going to simplify the square root of 48. So we're going to do a factor tree. So we need to think of two numbers that go into 48. I know 4 and 12 go into 48. And 4 and 3 go into 12. And what we're looking for are groups of 2. So right here, I see that we have two 4s. So that means we can pull a 4 outside of the square root sign. And then that 3 doesn't have a pair, so that's going to stay underneath the square root sign. So the simplified answer of the square root of 48 is 4 square roots of 3. Another way that you could do this problem is we know 4 and 12. 4 simplifies into 2 and 2. 12 simplifies into 2 and 6. And 6 simplifies into 2 and 3. So if you were to do it this way, you'll notice that we have two groups of 2. That means we're going to pull two 2's out in front, and we're going to multiply them together, and we'll still have that 3 left over for underneath the square root sign. So 2 times 2 is 4, and we have the square root of 3. So there are multiple different ways to do these factor trees, but as long as you're pulling out groups of 2 and multiplying them up front, then you'll still end up with the same answer. Moving on to part B. This one you'll notice we have a fraction, and in the denominator we have a square root. And it is a rule in math that you're not supposed to have a square root in the denominator. So whenever that happens, you are going to multiply the numerator and the denominator by that square root. So we're going to take the top times the square root of 3 and the bottom. And whenever you have two square roots being multiplied together, you are just going to multiply those two numbers underneath the square root sign. So then we'll have two square roots of, that would be 225 all over. And you'll notice we already have a group of two 3's. So the bottom is just going to become 3. And then you can do a factor tree if necessary. But the square root of 225 is 15. So we'll have 2 times 15 on top, which is 30, divided by 3, which will be 10. So that's one way you can simplify when you have a square root in the denominator. Now the next one, we have numbers and variables, which we're going to do the same thing. 72 factors into 6 and 12, 6 and 2, and I see right away that we have a group of 2 6's, so we can pull that outside of the square root sign. And then we have a leftover 2, so that has to go underneath the square root. We also have to do the same thing for all of these x's. So this is x being multiplied by itself 5 times, and we're looking for groups of 2. So we have 1, 2. So we're going to take 6 times x on the outside, and we have 1x left over for the square root. Then when we're to simplify this, we would have 6x squared times the square root of 2x. And that would be our simplified answer. Our next one. There are two different ways to do this, and I'm going to show you both of them. One is by yourself, by hand doing the math. The other is using the calculator. So what this means, 2 square roots of 5 in parentheses squared, means we're taking 2 square roots of 5 multiplied by itself. So what we're going to do is we're going to take the whole numbers up front and multiply those, so that will be 4. And then we're going to take the square roots and multiply those together. And like we talked about, when you have the square roots being multiplied together, you are just going to put them both under the square root sign and multiply them. So we still have that 4 up front, and we already have a group of 2 for the 5s. So we can pull that out, and we would have just 5. So our simplified answer would be 4 times 5, which is 20. Now, when you're putting this into a calculator, there's something that I want you to be careful, and that would be the parentheses. So if we type it in exactly what it looks like on your paper, we would have 2 square roots of 5 in parentheses squared, which we'll see on this calculator that equals 20. Now, if you were to just write 2 square roots of 5 squared without parentheses, you'll notice we got 10. So those parentheses do change your answers, because without them, the squared only applies to the square root of 5 and not the whole number. So when you type it into your calculator, make sure you put those parentheses because it makes a difference. Another thing that we're going to be doing this chapter is Pythagorean Theorem. Hopefully this is review because we have done it before. And we use Pythagorean Theorem. When a triangle is a right triangle, the sum of the squared lengths will be equal to the square of the hypotenuse. So that would be our equation, c squared equals a squared plus b squared. Another thing we're going to talk about are Pythagorean triples. And if you have some of these memorized, it might make some of your problems go a little bit quicker, but if you don't have them memorized, that's okay. A Pythagorean triple are the numbers a, b, and c that satisfy a squared plus b squared equals c squared. And you'll notice they're all whole numbers, so we don't have any decimals here. So if we were to plug these into the Pythagorean theorem, it would be a true statement. And one thing I want you to remember is that c is always the longest side. Or it's always the biggest side number. So in all these, c would be the last number. And then a and b, you can switch around if you need to. So example 1. A right triangle has a leg of 3 inches and a hypotenuse of 5 inches. They want us to find the exact length of the missing leg. So a leg of 3 inches, a hypotenuse of 5, and we're looking for our missing leg. We will be using the Pythagorean theorem of a squared plus b squared equals c squared. So we can start by labeling our triangle, and remember c is always across from that right angle. And then we can plug these into our equation. X squared plus 3 squared equals c squared. And you can use any variable, so you don't have to replace the a with an x, you can leave it as a if you want. Then if we work through and square everything, we would get x squared plus 9, oh, I was supposed to put a number there, 5, equals 25. Then we'll subtract 9 on both sides, and we'll get x squared equals 16. Then we will take the square root of both sides. Now remember, when you take the square root, when you're solving an equation, you get 2 answers, plus or minus 4. But because we are working with side lengths of a triangle, we are just going to be taking that whole number here. So our missing side of the triangle would be 4. And you'll notice this is one of our Pythagorean triples, 3, 4, 5, because all of them are whole numbers and they work in the Pythagorean theorem. Moving on to number 2. A right triangle has the leg lengths of 4 and 6. This time, we're going to find the length of the hypotenuse. So we're going to start by drawing a picture. And the lengths are 4 and 6 of the leg, and we're looking for the hypotenuse. C is always across from that right angle, so C is going to be my x value, and A and B can be either 4 or 6. Plugging that into the Pythagorean theorem, we would have 6 squared plus 4 squared equals x squared. And we would get 36 plus 16. Add those together, 52 equals x squared. And you'll notice that when we take the square root of this, if we were to type it into a calculator, the square root of 52, we will not get a whole number. So that means we need to do a factor tree. So last chapter, we were able to give decimal rounded answers. This chapter, we are expected to do the exact answers with the simplified square root. So over on the side, I'm just going to do the square root of 52. Now, off the top of my head, I don't know two numbers that go into 52, but I know it's even. So right away, I know 2 goes into there. And if we were to take 52 divided by 2, we would get 26. And right away, I know 2 goes into that again because it's even. And that would leave us with 13. And only 1 and 13 go into 13, so we know we're at the end of our factor tree. So we can pull a 2 out front, and underneath the square root, we will be left with a 13. And that gives us our exact answer on our side length of a triangle. And if you ever want to check your answer, we can just type this into a calculator. So we know we found the square root of 52 already, and that was 7.2111. So now we can type in 2 square roots of 13 and compare those answers. And you'll notice they are the same. So we know we simplified our work correctly. We will also be doing word problems in this chapter. For example 3, we are told we have a 16-foot ladder that rests against the side of a house. The base of the ladder is 4 feet away. Excuse me. And we're going to approximate how high above the ground the top of the ladder is. Keyword is this one is we're going to find the approximate value. So this one, it is okay to round our answers if necessary because they did say approximately. So we'll start by drawing a picture to help us get a visual of what we're looking at. So we start with a 16-foot ladder, and ladders are usually leaned up against buildings. So I'm going to draw that slanted, and I'm going to label it right away. That's 16 foot, so we do not mix it up in our picture. And it's leaning against the side of a house. So you can either just draw a line for the house, or if you want, you can actually draw a house. There's my little house. And they tell us that the base of the ladder is 4 feet away. So here's the base of the ladder, and that's 4 feet away from the house. And it is safe to assume that any building, tree, or anything is going to form a right angle with the ground. So that gives us our right triangle. Now we're looking for the height of the building, which is going to be x. So we have our C, A, and our B value. Now we can plug it into the Pythagorean theorem. So we'll have 4 squared plus x squared equals 16 squared. We'll have 16 plus, and I don't remember what 16 squared is off the top of my head. 256. Yep. And then on both sides, we'll subtract 16, which will give us x squared equals 240. Now remember, this one, it did say approximate, so we can type this into our calculator to get the approximate value of x. So we don't have to get that exact answer. So that'll save us some time because we won't have to simplify the radical. And this will be about 15.5. And don't forget your label, feet. And that's our answer. Okay. So now if you want to try the next example on your own, you can pause the video and attempt that to see how you are doing with the word problems. So for this one, it told us that the top of the ladder is resting against the wall that is 23 feet above the ground. So this time they don't give us the length of the ladder, they give us the length of this wall here. So that's 23 feet. And the base of the ladder is 6 feet away from the wall. So that's down here with our right angle. And we're looking for the length of the ladder. So again, C is going to be across from that 90-degree angle. A and B is okay to switch around. So we'll have 23 squared plus 6 squared equals C squared. So I'm going to add those together on my calculator. And we're going to get 565. And this one, it is okay to round your answer. I forgot to put it in the directions, but it is okay. So we'll get about 23.8. And that would be the approximate value of how long that ladder is. Okay. The last thing we're going to go over is area of a triangle. So area of a triangle, we can get from looking at the area of a square or a rectangle. So to find the area of a rectangle, we take the base times the height. In a square, both of those numbers are the same. In a rectangle, they don't have to be. If we were to cut that in half, you'll notice that we have a triangle. So we know the area of a rectangle is base times height, and you can see a triangle would be half of that. So what we're going to do is we're going to take the area of that and we're going to multiply it by 1/2, base times height. So here's our triangle. Remember, the height is always given from the altitude. And then the base is the entire length of the bottom part. So that is our base. So to find the area of a triangle, you are going to take 1/2 times the base times the height. So let's do some examples. We're going to find the area of an isosceles triangle. Remember, that means two sides are the same length. And they have the side lengths of 10, 13, and 13. So whenever you draw the isosceles triangles, you are always going to want to put the sides that are the same length on top, and then the side that's different on the bottom. So we're going to have 13, 13, and 10. And then we need to draw an altitude because this is not a right triangle. So we need to find the height of our triangle. And because this is an isosceles triangle, this altitude actually is going to cut this base in half, which means each side length is going to be 5 here on the bottom now. So we no longer have that 10. Now, if we look at just the right side of this triangle, you'll notice we have a right triangle, which we can use to find the height. So we know 13 is C because that's across from the right angle, and then A and B can be our H and our 5. So we'll have 25 plus H squared equals 169. Then we'll subtract that 25 on both sides. And we'll get H squared equals 144. And if we take the square root, that's where we're going to get 12. So originally we knew our base was equal to 10. And now we just figured out that our height is equal to 12. So to find the area, we are just going to plug those into our formula. Area equals 1/2 base times height. So we're going to have 1/2 multiplied by 10, which is the base, and multiplied by the height we just found, which is 12. Now you can type this into a calculator, or you can work it out by hand. I know 1/2 of 10 would be 5, and then we have 5 times 12, which would be 60. And when you find area, remember you put your units squared. So this is going to be 60 meters squared. All right, if you want to go ahead and try the next example on your own and then press play when you're done, you can go ahead and do that. So again, we're going to find the area of an isosceles triangle. Draw my picture here. And this one has a side length of 30, 18, and 18. I'm going to start by drawing my altitude really quick. And remember that altitude cuts the base in half. So we already know our base is 30. And now we've cut that in half. So each of these lengths would be 15. Now we can use that information to find the height of our triangle. So we're looking at just one of the right triangles. You could use the left one or the right one. You'll still end up with the same answer. And plugging it into Pythagorean Theorem, we would have h squared plus 15 squared equals 18 squared. 15 squared is 225. 18 squared, let's see, just double check my math here, 324. And then we will subtract that 225 on both sides. And that'll leave us with h squared equals, let's do some borrowing here. Let's see if I did that right. Yep, 99. Okay. And then we would take the square root there. And this one we do need to give exact answers. So I know 9 times 11 goes into 99. And 3 and 3 go into 9. So that would give me my group of 2 that I'm looking for. 3 square roots of 11 for my height. So we have our base and we have our height. Now we can plug it into our area formula. So area is going to equal 1/2 times the base of 30 times our height of 3 square roots of 11. Now for these you want the exact answer. So we are not going to type the square root of 11 into our calculator. So if you were to type this into your calculator, all you are going to type in is the 1/2, the 30, and the 3. And you're going to leave the square root of 11 in your answer. So I'll show you what that looks like on a calculator. So 1/2 we know is 0.5 times 30 times 3. So we're just going to multiply those three numbers together and we will get 45. So your answer is going to be 45 square roots of 11, and this is going to be feet squared. So unless they tell you to round, you should be giving exact answers on your homework, on quizzes, and on tests. All right, so if you have any questions on this section, just let me know and I will get back to you.